Now, in the last lesson, we were taking a look at the different sizes of square ponds that we were building and figuring out how many square tiles it would take to surround those ponds. The one we started with had a side length of 4 feet, and the tiles, it would take 20 tiles. All the tiles are 1 foot by 1 foot. And then we made a 3-foot sided pond and came up with the fact that it would take 16 tiles to surround that pond, 3 and 3 and 3 and 3, and 1 and 1 and 1 and 1 at the corners. If there were 5 feet side lengths, it would take 24 tiles. If there were 6-foot side lengths of the pond, it would require 28 tiles. And we figured that all out in the last lesson. And then after we did that, we set up a table. And we decided, and we set up the table, the side length would be our input, our X value, and the number of tiles would be our output or our Y value. And so we had 3 and 16, 4 and 20, 5 and 24, 6 and 28. And then just for fun, how many would 7 be? And somebody correctly answered 32. And then I jumped up to 15. What if there were 15? What if 15 was the side length of our pond? How many tiles would it take? And that's kind of where we left off. So today, let's take a look at this. And first of all, we're going to graph this data. So let me enlarge the size of the red mark that I'm going to make, and we'll graph this bad boy. Now you can see I've already numbered my graph. So if you want to number your graph, that would be perfectly fine. You can see that on this, I went in a little bit because I found that that's kind of an easier way to do these graphs. But then I skipped every other line because I didn't want to number all of them and just crowd everything in. So first of all, a side length of 3. So I'm going to go right between 2 and 4. And a side length of 3 had 16. So here's 10. That would be 15. That's 20. So I go back to about there, I think. 4 would require 20 tiles. So over to 4 and up to 20. 5 would require 24. Well, there's 25. So it'd be just slightly below that. And 6 was 28. So there's 25. There's 30. I got to come down a little bit. That looks about right. 6 and 28 and 7 and 32. So up to 30 plus a little more. Yeah. And that looks like it's coming out to be a pretty nice straight line. Let's see if we can extend that line now through the graph to the y-axis. Let's see, I'll start here, I guess. And we'll go, no, that didn't work out. A little bit off. Try that again. And that looks pretty good there. Hold on a second. Okay. And then if I wanted to, I could extend this line, further out, and maybe I'll try doing that. Yikes. All right. Obviously not very good when I'm trying to do it free-handed. But there's our graph. And you can see, interestingly enough, when you notice where it crosses the y-axis, it doesn't cross the y-axis at the origin, does it? So that's important to understand. Whoops. Okay, so let's continue on. We've graphed it. So moving on to page 87 then, we want to write an algebraic rule that represents the relationship between the side length of the pond, which is our y value, and the number of tiles needed to surround the pond, which is our, I'm sorry, I got that backwards. The side length is our x value, and the number of tiles needed to surround the pond is our y value. So What do each of these numbers and letters in the rule represent? So remember, we want to write this algebraic rule, and that algebraic rule is going to look something like, y equals something, right? So if we take our, the values that we had from the table or the graph, and remember, we had x and we had y. When x was 3, y was 16. When x is 4, y is 20. When x is 5, y is 24. And that should probably be enough to let us know how to get there. So we've got to figure out what is our process to get from x to y. Okay, so what are we doing to take 3 and make 16, right? So one of the things we could look at is, all right, let's try multiplying. Can we multiply anything times 3 to make 16? No, we can't, right? 3 times 5 is 15. That's close, but not enough. So obviously that's not going to work. How about 3 times 4? Well, 3 times 4, so 3 times 4 is good. That's 12, but then how do we get from 12 to 16? We have to add 4 to that. 3 times 4 plus 4. So 3 times 4 is 12 plus 4 is 16. All right, will that work for the next one? How about 4 times 4? 4 times 4 is 16 plus 4. It's got to be the same rule every time, right? 16 plus 4 is 20. Oh, I think I see what we've got going on here. How about 5 times 4? 5 times 4 is 20 plus 4 is 24. So we can see in our process column that in order to get from our x value to our y value, we have to take x, or whatever the x value is, multiply that times 4, and then add 4 to it to get our y value. So now what that means is in order to find y, we have to multiply x times 4, which is 4x. Let me scroll up a little bit here. 4x, and then we have to add 4 to that. And that is how we would get our y value. So there's our algebraic rule. The number of tiles that it takes is you take 4, you multiply it by the length of the side of the pond, and then you add 4 to that. See? Beautiful. So what do the parts of the rule represent? Okay, that's question C. So let's talk about this here. Take it one step at a time. Y is the number of tiles. X is the length of the side of the pond. And then the 4 that's multiplied by the x, that's called the coefficient of x. The 4 in 4x is, well, that's the number of sides of our pond, right? There are 4 sides to the pond. So that 4 represents those 4 sides. And then that last 4, the final 4, the 4 at the end, that is our 4 corners of the pond. The 4 corner tiles. All right. So, are there any questions about that yet? Does that make sense? Because we could certainly draw a picture of this. So if we've got a pond, and we'll make it simple, we'll just do 3 feet on a side. So Then I'll change the colors here. Then we've got, see, we got 3 on that side, 3 on that side, 3 on that side, and 3 on that side. So there are the 4 sides multiplied by the side length of 3. So that's, remember, y is equal to, in this case, the 3 times the 4 sides plus, then we have to add, oh, come on. There we go. We have to add the 4 corners. The 4 corners. Okay. So that's how we end up with y equals 4x plus 4. Now moving on to this next question, question D. Is the relationship in the graph proportional or non-proportional? So think about it. When we look at each of these values in the table, when we divide y by x, do we get a constant? Is there a constant value? 16 divided by 3, 20 divided by 4, 24 divided by 5. No. There's no constant value when we divide. On the graph, does it pass through the origin? Does it go through 0, 0? No. In the equation, is it just simply y equals the constant multiplied by the input of x? No. There's that 4, those 4 corners that get added. So it's not proportional. So since it's not proportional, this question here that asks, what is the constant of proportionality? There is no constant of proportionality. There can't be a constant of proportionality if it's not proportional. We can certainly find the slope of the line, but we won't be able to find the constant of proportionality because it's not proportional. So going back to our graph, now looking at question E, does the point 0, what does the point 0.04 represent? What about the point 0.18? Okay. So what would 0.4 represent on our graph? Remember, 0.4, that's an XY pair, right? An ordered pair of XY. So if we look at our graph, 0.4 would be right here, 0.4. So what does that point mean? Well, the 0 in this would be, it would have a side length of 0. And if it has a side length of 0, that means, and then it would have 4 tiles to surround it. Interesting, right? So 0.4 means that it would have no side lengths. So basically just a dot. But in order to have that dot, to surround that single dot, you would have to have 4 tiles around that single dot, which has no length to it. So 0.4 means, hold on a second. side length of 0, and 4 tiles around it. All right, but what about 1/8? 1,8. Well, that means that we would have a side length of 1 by 1, and it would take 8 tiles to surround it. So you'd have to have 1 there, 1 there, 1 there, 1 there for each side. And then you would have to have the 4 corner pieces. 1, 2, 3, 4, 5, 6, 7, 8 to surround that. So 1/8 means that you have a side length of 1, and it would take 8 tiles to surround it. Now, of course, you could have a pond that has just, it's only 1 foot by 1 foot. You could put little tiny goldfish in it. But would you have a pond that has 0 for the side length? Is that a pond? No, it's not a pond. So that doesn't make sense. So one of these makes sense. Yay. Happy face, right? If I can draw a happy face, there we go. But this one, that one doesn't make any sense at all, because you're not going to have a pond that has no side lengths. Hello. That's just silly. Okay. Now, moving on to page 88, the equation that represents the relationship between the side length of a pond and the number of tiles is this. Now, see, they have replaced y and x with t and s, and that's okay. So this is saying that the number of tiles that are needed is equal to 4 multiplied by the side length plus 4 more tiles at the corners. And we could use this to find the number of tiles needed for any size pond. Like, for example, how many tiles would you need for a pond with a pool side length of 5? Well, that's pretty easy to do. We see, all right, the number of tiles necessary would be equal to 4 multiplied by a side length of 5 plus the 4 corners. So that's going to be 20 plus 4, which equals 24. So the number of tiles necessary would be 24. 24 tiles. Beautiful. Thank you for the time reminder. Now, with this, I just don't have time to finish it. So you guys have a bit of a break.